of the assignment is as follows. We have two random walkers, the cat at position 0, 0 and the rat at position L, L in a grid of size L, where L is the length. Also, the grid size is of length 1, that is, this unit length is 1. And n is the number of grids, that is, the number of boxes, as you can see. So, the question is as follows. We have to find the survival probability of the rat in two cases. By survival, I mean that the cat and rat do not meet at the same point at any given instant of time. So the two cases are 1. The cat begins at 0, 0 and rat at L, L, or the second one is the cat and rat both begin at the center of the grid. We solve analytically for both of these cases. However, before solving for this particular case, let us solve this same problem analytically for a general case of x, y coordinates. So let us begin with it. We first find the approximate probability distribution for one random walker. Let the probability that the random walker be at a position x, y and t plus delta t is as follows. P of x minus delta x, y, t plus P of x plus delta x, y, t and so on. That is, at time t, we consider the random walker position x minus delta x as well as x plus delta x. Similarly for y. Also, we subtract P of x, y, t from the LHS and RHS as well and get the following expression. In the previous expression, if we divide the LHS and RHS by delta x squared, delta y squared, delta t, this is what we get. Also, this expression, when divided by delta t, we get del p of x by t, by del t. And this is what we get in the RHS. Also, the RHS can be further simplified as follows, which is del square p of x by t divided by delta y square del x square and the same for del y square. Also, let us consider delta x square by 4 delta t as dx and delta y square by 4 delta t as dy. So this is the equation which we get, and this